Pick the most distant galaxy you can find, a faint smudge of light at the limit of the deepest telescope, and imagine pointing a ship at it and flying faster than anything ever built for as long as you like. You will never reach it. You will never reach any edge at all, because the edge of the universe is not sitting out there in space, waiting for you to arrive. It is running away from you in every direction at once, at the speed of light. There is no wall, and yet there is unmistakably an edge, the farthest thing you can ever see. So if it is not a wall and not a place, then what exactly is the edge of the universe? The answer is one of the strangest ideas in all of science, and it begins by throwing away the picture in your head. There is no dark barrier at the rim of everything, no fence with a sign that says the universe ends here. The edge is not a place, it is a moment. What we call the observable universe is simply a sphere containing everything whose light has had enough time to reach us since the beginning. Light is fast, but it is not infinitely fast, and the universe has only existed for a certain span of time. So there is a distance beyond which light has not yet arrived, and that distance is the edge. It was pieced together over a century from Edwin Hubble's discovery in 1929 that the universe is expanding, to a faint hiss two astronomers found by accident in 1965 that turned out to be the oldest light in existence. Together they tell us the edge is real and that it is made of time. Start with where the edge is. It is centered on you, not on the Earth, not on the sun, not on some special point in space, on the observer. Every direction you look, light has been traveling toward you for the same maximum span. So you sit at the exact center of a vast sphere, and the edge is the shell of that sphere. This sounds impossibly arrogant, as though the whole cosmos were arranged around your eyes. It is not arrogance, it is geometry. An astronomer in a galaxy billions of light years away sits at the center of her own sphere, a different sphere, overlapping yours but not identical. There is no single edge of the universe that everyone shares. There are as many edges as there are observers, and each one carries their horizon with them wherever they go. Now look outward and notice what you are really seeing. The light from the sun left it 8 minutes ago, so you see the sun as it was 8 minutes in the past. The light from the nearest star is 4 years old, and the faint galaxies at the limit of our telescopes are showing you light that has been traveling for well over 13 billion years. To look far into space is unavoidably to look far back into time. Every telescope is a time machine, and the deeper it sees, the older the scene. The James Webb Space Telescope was built for exactly this, to catch the extremely faint, extremely stretched light of the first galaxies, forming just a few 100 million years after the beginning. The current record holders are galaxies whose light left them when the universe was barely 300 million years old, a 20th of its present age. On Webb's detectors, they are the faintest smudges of infrared, light so stretched by its billions of years of travel that it left as visible starlight and arrives as heat. We are seeing the cosmos in its infancy, frozen in the act of switching on. As you push your gaze toward the edge, the galaxies grow younger, wilder, more chaotic, and then they run out. Not because the universe runs out, but because you have looked back as far as there is light to see. And when you reach that limit, you hit something astonishing, a wall of light. In every direction, at the very edge of what can be seen, the whole sky glows with a faint, even microwave hum. This is the cosmic microwave background, and it is the oldest light in the universe, released about 380,000 years after the Big Bang. Before that moment, the cosmos was so hot and so dense that it was opaque, a fog of charged particles in which light could not travel freely. It scattered endlessly, trapped. Then the universe cooled just enough for atoms to form. The fog cleared and light streamed out for the first time. That first light has been traveling ever since, stretched by the expanding universe from a fierce glow into cold microwaves. When you look at the edge, that is what you see. Not a barrier, but the afterglow of the moment the universe became transparent. The wall of light is the surface of the observable universe. So what is behind the wall? The honest answer is that with ordinary light, we can never look past it. The microwave background is not the edge of the universe. It is the edge of what light can show us. Behind it lies the era before atoms, the opaque fog, and light from there can never reach us directly. It was scattered away before it could begin its journey. This is a genuine curtain across the cosmos, and it is not one we can pull aside by building a bigger telescope. To see behind it, we would need messengers that do not care about the fog, neutrinos, which slipped through almost untouched, or gravitational waves, ripples in space itself from the first fractions of a second. Neutrinos from that era are still streaming through you right now, trillions every second, left over from the universe's first full second of life. But they interact so weakly that catching even a handful would take a detector the size of a small sea. Gravitational waves from those first instants are fainter still. We are only beginning to learn how to catch them. For now, the universe keeps its earliest chapter hidden behind a wall of its own light. Here is where it becomes truly strange. The universe is about 13.8 billion years old, so you might expect the edge to be 13.8 billion light years away, as far as light could travel in that time. But it is not. The edge is more than 46 billion light years away in every direction. How can light have crossed 46 billion light years in only 14 billion years? The answer is that it did not. While that light was traveling toward us, space itself was stretching, carrying its source ever farther away, like a runner on a track that keeps getting longer beneath their feet. The light covered 14 billion years of travel, but the ground it started from has since been swept to more than 46 billion light years distant. The most remote galaxies we can see are now receding faster than light, not moving through space, but riding the expansion of space itself, which is bound by no speed limit at all. So the edge is farther than it has any right to be. And that raises a harder question. Is there anything on the other side of it? Because the observable universe is not the whole universe. It is a bubble, the region close enough for light to have reached us, floating in something far larger. How much larger, we do not know. The universe may be hundreds of times bigger than the part we can see. Every measurement we can make says space is flat as far as we can measure it. And a flat universe, if it closes at all, closes on a scale so vast it may as well be endless. We have no evidence of a far side and no reason to expect one. It may be infinite, stretching on without end, filled with galaxies we will never observe because their light will never, ever arrive. And crucially, there is nothing special about the wall we see. It is not the outskirts of creation. Cross it, and you would find more ordinary galaxies, more stars, another observer looking back toward where you came from and seeing their own wall of light. The edge feels like the boundary of everything. It is only the boundary of everything we can see. And now a second, different horizon comes into play. The one we have followed so far, the edge of what light has had time to reach us, will keep growing. But the expansion of the universe is not just continuing, it is accelerating, driven by a dark energy we still barely understand. And that acceleration draws a new line around us. The farthest anything can be, and still, one day, send us its light. Beyond that line, galaxies are lost to us for good. Distant galaxies are being carried away faster and faster, their light stretched redder and dimmer, until one by one they slip beyond our reach and wink out of view forever. Given enough time, 100 billion years, a trillion, almost every galaxy now in our sky will have crossed that horizon and vanished. A civilization living in that far future would look up and see only our own small cluster of nearby galaxies, marooned in an ocean of empty black. They would have no distant light to reveal the expansion, no wall of ancient glow, no way to deduce the Big Bang at all. They would conclude, reasonably and wrongly, that the universe is small, static, and eternal. The evidence will have quietly left the sky, which makes the edge of the universe not a thing, but a warning and a gift. It is not a wall you could ever touch. It is a horizon made of light and time, and it moves with you, always receding, no matter how far or how fast you chase it. But it is also a window, open for a little while. We happen to live in the brief cosmic morning when the universe still shows us its own distant past, when the wall of light still glows and the far galaxies have not yet fled. Look at the edge while you can. It is the farthest the eye will ever reach, a boundary in time wearing the disguise of a boundary in space, a horizon that will move with us to the very end and never once let us arrive.